Hello IB, we're now going to look at graphing quadratic functions. You've already done a lot of these and I'm sure by now we recognize the parabola shape. It's interesting that the shape comes out of a conic or out of a cone. So this diagram here shows how we can from a cone get the different shapes. So we've got the circle that comes from cutting straight across the cone. If you cut it at the angle you get the ellipse. This is our parabola here. And then with the hyperbola is if you cut it at a different angle, you get that hyperbolic shape. This other diagram also shows you if you use the double cone, you can get different parts and how you get the different parts of the hyperbola when you cut it straight down. The key features of our parabola these are the ones here that you need to know and we've already been looking at. So we've looked at the zeros. So we've talked about the zeros and the roots or the x-intercepts. And remember those you can get algebraically when y is equal to 0. Then we've also talked about concave up, that shape. And obviously if it's concave up, then we've got a minimum value here on the parabola. If it's concave down, then we're talking about a maximum. We can also talk about the y-intercept. So that's when we've got x equal to 0, if you're doing that algebraically. So your y-intercept here on this function here, we've got it at -4. And the vertex, the lowest point of the curve, so our vertex over here, here's our vertex, we've talked about that, which is in this case a minimum, or it could have been a maximum. The other one we want to look at was the axis of symmetry. So the axis of symmetry, come back here. Your axis of symmetry is the line where we can just cut down and divide it in half. So let's go orange. So our axis of symmetry is not there, but it gives me a line to work with. It goes right through the vertex. The equation for an axis of symmetry means we want an equals. It's an x value, so it will always be x equal to something. In this case, it's looking like -1.5. In here, -1.5 is the axis of symmetry here. So the equation will be x equals, because it's a vertical line. That's a little bit better. What we're going to do in our next class is do an investigation and looking at a whole range of different ways of doing our parabola. And we've already started to cover these, so it's a bit of revision. So in the first one here, we're looking at factored form. Oh, we want a pen. So this is our factored form where we've got it written in the different factors. So we might, in a quadratic, we may have 2 factors, or we may have, in this case down here, just 1 factor. The other key thing in this general equation is that we've got an a value. So the a is going to be telling us something about the function. In this case, our a value is 1. Here it's 2. We've got -1.5. So you'll have a look and see how does the a value affect our graph. In our graph here, we see we have just 1, 0. Means we've got 1 factor that's repeated. So this is like a repeated factor. So we only get 1, 0. So this graph here is probably one of these 2 functions. You have to work out which is the red and which is the purple. The next one we'll be looking at then is the vertex form. So in the vertex form, we can see that it's written again without an a value that's been factored out the front. And then we've got h and k. So where h and k is the vertex, the coordinates of the vertex. Note, it's when we have -h and we're going plus k. So in this graph here, what we've done is we've started with a y equals x squared, which would look like 2 is 4, 4, 1, 1, and we'll try, what have we got? 4 is 16, 16, 3 is 9. Let's see how good I am at doing this curve. There, up there, bit wobbly. Obviously it keeps going. So we've started with an x squared, and in each process we've had a shift of our function. It's still the same shape, but in the first case we've done a shift left, and we'll do more of this in another chapter later. And now, oh, that's a T, and then we've got a shift up. So our vertex has moved from this position at 0, 0 across to here, and then it's gone up to here. So you'll be investigating that, and again, the effect of the A value. The next one here, I've just shown a different one where we've got the different A values. So here, same function with the vertex, but what effect does that, the A value out the front, how does that change your graph? So we'll look at that. We then want to look at graphing quadratic functions by completing the square. So we've been doing a lot of this in class already. So remember to complete the square. We're not solving it by completing the square. We're just rearranging the equation. So I like to go x squared plus 6x and then put my plus 7 over here. So I want to add something in here. Remember, you halve the 6 to 3 and then square it to make 9. And if we add 9, we've got to subtract it. And that way we're not changing the equation. So this is the same as y equals x. Half the plus 6 was plus 3 squared. Plus 7 minus 9 is minus 2. So now we can see that our vertex, hk, is minus 3, because remember it was x minus h, is going to be at minus 3 minus 2. So if I want to draw this up, no, sorry, move these over. Okay, so we're starting with minus 3 minus 2, so let's say that's minus 3 minus 2. We know that point. From the original equation, we know that our y-intercept is at 7. Let's put a bit of a scale on here. Minus 3 minus 2. 2, 4, 6, 7 is probably going to be up here. Where are we? Blue. So we know there's a point here. And if we think about our axis of symmetry is here, it's totally symmetrical. So if I know I've got 3 units, this is at minus 3, so this here is 3 units, then I know there's going to be another point across here at 3 units. So I have another point here at 1 across here, which is going to correspond to minus 6 on the x-axis. Just want to make this a little bit longer. Let's try and just stretch it out a bit so we can get the axis happening. There we go. So even just with these 3 points, I can now sketch it in. It'd be easy if I also worked out the x-intercepts, but I'm not even going to worry about that for the moment. All right, so I can sketch it using the vertex, the y-intercept, and what's called the symmetrical point. So this here is the symmetrical point because it's reflected around that vertical line, the axis of symmetry. remember when you're having a go, oh, we don't want red, when you're doing your turning it into factored form, pull out your 2, that factor first, so you're left with x squared plus 2x, leave your space, plus 5. Now think what has to go in here to complete the square. So 2 divided by 2 is 1, square 1 is plus 1. So we've added 1, but it's times 2. So we've effectively added 2, so we want to now minus 2. So now we've got 2x plus 1 all squared plus 3. Alright, so that's just running through that process. Then this one, again, have a go, pause the video and see if you can have a go at factoring that and coming up with your graph. So pause the video now and have a go at this one. Okay, so I'm outside and it's starting to rain, but I'm not in the rain. So hopefully you were able to turn that into that vertex form and come up with this graph using your vertex, your y-intercept, and your using your symmetrical point as well. So our vertex at 3 minus 31, and our symmetrical point is here and over here. So at y-intercept was at minus 4 over here, 3 units across, that's 3, and then that's another 3. Alright. The next part is looking at that general form. In the general form, you should be able to find your x-intercepts. Oh, the rain! From when x is 0 to get your y-intercept, and from y equals 0 to get your x-intercept. So remember, to get your axis of symmetry, now I'm not sure whether you've done this last year, but you may remember that you can get your axis of symmetry from, it will be x equal to minus b over 2a. Does that ring a bell to find that axis of symmetry when you've got that general form with a, b, c, the ax squared plus bx plus c? To get your vertex, then that's going to be the point minus b over 2a, and then substitute that x value back into the function to get your y value. So hopefully that might ring a bell. The discriminant, that's part of your quadratic formula. We use the symbol of a triangle for the discriminant, and it's the part that is inside the square root, the b squared minus 4ac. So calculating that, it's called a discriminant because it discriminates different types of quadratics, and you'll also be looking at that, and we'll see what effect it has on the different quadratics. So this is just an insight on or a vision of what you should know or could know about your quadratics, and in class we'll investigate all these the 3 different types and the effect of the A's and the B's and the C's on everything. So thanks for listening and looking forward to seeing you in class. Bye for now.